In this lecture, we're going to start chapter 1, equations and inequalities, and we're going to start with section 1.2, which is linear equations and rational equations. So the first slide starts off with the definition of a linear equation. Many of you are familiar with linear equations in one variable, and our general form is ax plus b is equal to 0, where a and b are real numbers, and a can't be equal to 0, or else we wouldn't have a variable term in there. And the goal is to solve for the variable, to solve for x. Now, there's many ways to approach these depending on what the equation looks like. So here's a quick list of steps to solving, an equation by creating equivalent equations. So we can remove grouping symbols and combine like terms if necessary. And we could also add or subtract the same real number or variable expression on both sides of the equation. We could also multiply or divide by the same non-zero quantity on both sides of the equation. We could even interchange the two sides of the equation. Really, as long as we're keeping the equation the same, meaning both sides are equivalent to what we started with, then, we're able to continue on and solve for x. You wouldn't want to, let's say, multiply one side of the equation by a factor, but not multiply the other side, because then think it's going to be unbalanced. It's not going to be an equivalent expression. So let's look at an example. Let's go to the first example, example 1. So this you're familiar with. You've definitely seen, solve and check a linear equation. And in A, we have 4x plus 5 is equal to 29. So the goal is to solve for x. So my first step, if necessary, would be to get rid of any groups, any parentheses by your distributive property and combine like terms. That's not necessary in this case because it doesn't exist. So my second step would be to collect all the variable terms on one side and get all the constant terms on the other side. So in this case, I'm going to subtract 5 since 5 is a constant, and I'm going to leave the variable term on the left by itself. So we're isolating the variable term. That's the goal. So 29 minus 5 is going to be 24. So we end up with 4x is equal to 24. We subtracted 5, from both sides of the equation. We kept it balanced. And now we want to solve for x, right? On the left-hand side, I have 4x. I want 1x. So if we were to divide by 4, as long as I divide the other side of the equation by 4, it stays balanced, right? So we're going to end up with x is equal to 24 divided by 4, which is 6. Now, you always want to check your answer. I'm not going to check our answer for every single one of these that we do just because of time. But for the first one, I will, but I encourage you every time you solve, check your answer. So let's check and make sure that x is equal to 6. So go back to the original, and wherever you see an x, we're going to replace it with a 6, right? So I'm going to get 4 times 6 plus 5. That should give me 29, right? And 4 times 6 is 24. 24 plus 5 is 29. So we're good. My answer checks out. Let's look at B. We want to solve 11x minus 6x minus 5 is equal to 40. So in this case, I do have to look at the first step here. We want to simplify the algebraic expression on the left by getting rid of grouping, right? We want to get rid of those parentheses, and in order to do that, I have to distribute that -1, right? That's in front of the grouping. So let's do that. So we're going to have 11x minus 6x, and then we have a -1 times a -5, which is going to be +5, and that's equal to 40. And now we can combine like terms, right? We could combine an 11x and a -6x. 11x minus 6x is going to be 5x, so we get 5x plus 5 is equal to 40. Now do what we did before in part A, right? Gather the constants to one side of the equation and gather the variable terms to one side of the equation. I only have one variable term. I have a 5x. So I'm going to bring the 5, the constant, to the right-hand side by subtraction, right? Because a positive 5 and a negative 5 would be 0, which is what I want because I only want 5x on the left-hand side, but then I have to subtract 5 on the other side of the equation to keep this balanced, right? So we're going to end up with 5x equals 35, right? 40 minus 5. And just like before, I want to have 1x. So 5x, right, has to be divided by 5 because 5 divided by 5 is 1. And then I divide the other side of the equation by 5. And we're going to get x is equal to 7. And again, you always want to check your answer to make sure that it's correct. Let's do one more. Look at part C. We want to solve for x. And again, we have to distribute on either side of the equation and combine like terms. That's what we have to do first. So first I'm going to distribute the 2 on the left-hand side, and then on the right-hand side, we have to distribute the negative 3. So I'm going to have 2x minus 2 plus 3 is equal to x minus 3x minus 3. Now I could combine like terms. So on the left-hand side, I'm going to have 2x. Negative 2 plus 3 is a positive 1. So 2x plus 1 equals, I could combine the x terms on the right, right? X minus 3x is going to be a negative 2x, and then minus 3. And now it's time to gather variable terms to one side of the equation and constants to the other side. It honestly doesn't matter which way we go. I'm just going to bring the x terms, the variable term, to the left just to keep that positive, because if I add 2x to both sides, I'm going to end up with a positive x term. And then I'll bring the constants to the right-hand side. So look, I'm going to add 2x to both sides of the equation. So I'm going to get 4x plus 1 equals negative 3. And let's finish this over here. So we get 4x plus 1 equals negative 3. And now I'm going to subtract 1 from both sides to get the constants to the right. So that's going to be 4x equals negative 4. And now we could divide by 4. And we're going to get x is equal to negative 1. And again, make sure you check your answers. So we're going to continue solving equations, but now we're going to have rational equations. So what's going to be different about the next example is that I'm going to have fractions within my equation. So look at example 1, right? A, B, and C. We didn't have any fractions in there, right? But now look at this next example here. This is called, what I just circled, a rational equation because it contains one or more rational expressions or fractions, right? So in this equation, right, we see the equal sign. I have 3 different fractions. So we call this a rational equation. My approach to solving rational equations is to, rather than trying to look at, like, let's say an A on the right-hand side, rather than trying to combine those 2 fractions and then cross multiplying, what I think is easier, and this is the method or the technique that I'm going to show you, is let's just get rid of fractions altogether by multiplying the entire equation by the least common denominator. I prefer not to work with fractions, right? It's just kind of easier to not work with fractions. So why don't we get rid of them at the beginning? But we're still going to keep both sides of the equation equivalent by multiplying both sides by the same exact factor, which is going to be the least common denominator. But you're going to see it's going to get rid of fractions and it's going to make our life so much easier. So like, look at example A. Look at, like in this case, we have 1, 2, 3 fractions, right? Look at the 3 denominators. What is our common denominator, right? So let's think about what's the least common denominator. what does a 7, a 4, and a 14 go into? What's the smallest number that those three numbers go into? That's going to be our least common denominator. And what I'm going to do is I'm going to multiply both sides of the equation by the least common denominator. And you're going to see we're going to get rid of fractions. So my least common denominator is going to be 28 in this case, right? A 4, a 14, and a 7, the smallest number that they all go into is going to be 28. So what I'm going to do is I'm going to multiply the entire equation by 28, or 28 over 1, if it's easier. Because when we multiply fractions, we multiply across the numerators and we multiply across the denominators, right? There's no cross multiplication going on. So I'm going to multiply everybody by the least common denominator of 28. But when you do this, don't distribute, just multiply, because you're going to see what's going to happen. We're going to be able to reduce each one of these fractions by a common factor, and there aren't going to be any more fractions. So look, we're going to have 28 times x minus 3 over 1 times 4, which is 4. That's going to equal now 28 times 5 over 1 times 14, which is 14, and then minus 28 times x plus 5 over 1 times 7, which is 7. So now look, and I'll do this in red. 4 goes into itself once and into 28 7 times. 14 goes into 28 twice. And 7 goes into 28 4 times. So you see how I was able to reduce, right, by the common factor in each expression. But now look, I'm not going to have any fractions left. All that's left on the left-hand side is 7 times x minus 3, right, over 1. That just became a 1. All these denominators became 1. That's going to equal now 2 times 5. And then minus 4 times x plus 5. No more fractions, right? This actually looks like one of the equations similar to the equations we were solving above, right? Just your typical linear equation with no fractions. So now let's distribute, combine like terms, and isolate x. So 7x minus 3 is going to be 7x minus 21. That's going to equal 2 times 5, which is 10. Now distribute the negative 4. So I'm going to have minus 4x minus 20. Combine like terms. So I'm going to have 7x minus 21 is equal to 10 minus 20 is negative 10. And then minus 4x. I'm going to gather the x terms to the left-hand side and the constants to the right-hand side. So look, I'm going to add 4x to both sides, and then I'm going to add 21 to both sides. So on the left-hand side, I'm going to have 7x plus 4x, which is 11x, equals negative 10 plus 21 is going to be positive 11. And now I could divide, right? If we divide by 11, we're going to end up with x is equal to 1. And again, check your answers. Plug x equals 1 into the original. And look, we'll do this in the calculator just to get a quick check so we don't have to, do it by hand. It's always going to be quicker, just to plug it in and check in the calculator. So let's do this together in the calculator. So we're going to check x equals 1. So I'm going to plug it into the original equation. So the left-hand side is x minus 3 over 4. So let's replace x with 1. So in the numerator, I'm going to have 1 minus 3. Make sure you keep it in parentheses. And then we're going to divide it by 4. So we get negative a half. So now whatever's on the right-hand side should equal negative a half. So now let's look at the right-hand side. So we have 5 divided by 14 minus, now the numerator is x plus 5, but remember, we're plugging in 1 for x. So 1 plus 5, keep that in parentheses. And then divided by 7. And we end up with negative 0.5. So that checks out. So x equals 1 is our solution. So let's look at the next example. For the next example, in part B, and let me just kind of separate over here. This way I have room. Okay. So for B, let's do the same thing. Let's multiply both sides of the equation by the least common denominator. So let's look at our denominators. I have a 2x, an 18, and a 3x. My least common denominator is going to be 18x, right? Because a 2, a 3, and an 18 all go into 18, right? But then we also have the x factor here, right? So we're going to multiply both sides of the equation by 18x, or 18x over 1. And you know what? Let me plug that in red so we could see it better. So we're going to multiply the entire equation by 18x over 1, and then we have to distribute. So we're going to have 18x times 5 over 2x. That should equal 18x times 17 over 1 times 18, which is 18. And then minus 1 over, I'm sorry, we have to multiply 18x times 1. So that's going to be 18x. And then over 1 times 3x, which is going to be 3x in the denominator. Now we can go through and simplify by reducing by our common factors. So 2 goes into 18 9 times. X over x is 1. Then we have 18 divided by 18, which is 1. And then we have 3 into 18 goes 6 times. And then we have x divided by x. So we're going to be left with 9 times 5 equals x times 17, or 17x, minus 6. 9 times 5 is 45, equals 17x minus 6. Now, let's leave the 17x where it is, and let's bring the constants by adding 6 to both sides. So we'll bring that to the left. So we're going to get 45 plus 6 is 51, is equal to 17x. Now we divide by 17. And x is equal to 51 divided by 17, which is 3. And again, go back, plug in your answer, and make sure that it checks. Now let's look at one last example. So for part C, we have 8x over x plus 1 is equal to 4 minus 8 divided by x plus 1. So if it makes it easier for you, make that 4 over 1. This way we have all fractions and it's just easy to see the denominators. So we have 3 denominators, an x plus 1, a 1, and an x plus 1. So we have to ask ourselves, all right, what's the least common denominator? So in this case, it's going to be x plus 1. So I'm going to multiply the entire equation by x plus 1 over 1. So I'm going to distribute x plus 1 to all my equations. So I'm going to have x plus 1 times 8x divided by 1 times x plus 1, which is x plus 1, equals x plus 1 times 4, right? Or 4 times x plus 1 over 1. And then minus, now I have x plus 1 times 8, or 8 times x plus 1, and that's over 1 times x plus 1. Now we could go through and reduce by common factors, and we're not going to be left with fractions, and that's the goal of this. So look, x plus 1 divided by x plus 1 is 1. Here, 4 over 1 is just 4, right? So we don't need to write the 1. And then in the third expression, x plus 1 over x plus 1 is going to reduce to 1. So on the left, we have 8x is equal to 4 times x plus 1, and then minus 8. So now we could distribute the 4. So we're going to get 8x equals 4x plus 4 minus 8. If I combine like terms on the right, we're going to have 8x equals 4x. 4 minus 8 is minus 4. And now let's gather the x terms to the left-hand side by subtraction. So I'm going to subtract 4x from both sides. 8x minus 4x is going to be 4x. And then equals negative 4. And now we could divide by 4. And we're going to get x equals negative 1. But remember what I said about checking your answers. Always check your answers. Look what's going to happen in this case when I go to check x equals negative 1. So let's go back to the original. Let me just get rid of this around it so we could see it more clearly. Here's my original, right? Let's go to check x equals negative 1. So if I go to plug in, I'm going to have 8 times negative 1 over x plus 1. But x is negative 1, so I'm going to have negative 1 plus 1. That should equal 4 minus 8 over, again, x plus 1, but I'm going to replace x with negative 1. But look at these denominators. What is negative 1 plus 1 equal to? That's equal to 0, right? Same over here. We can't divide by 0. It's not a real answer. It's undefined. So negative 1, think about what we did in previous videos. We were thinking about, okay, what should be excluded from the domain of these rational expressions? And in this case, x equals negative 1 needs to be excluded, right? It's not part of the domain, or it can't ever be part of a solution set because it's giving our, denominator a value equal to 0, and we can't divide by 0. So we have to reject this answer. It's not a possible answer. So there's actually no solution. So again, I can't stress how important it is to always check your answers. And this would be an example where our answer doesn't check out, right? It's not making any sense. So there's no solution. So I'm actually going to stop here. I'm going to start another video after this one that'll cover types of equations, and then we'll do some application questions, word problems, where we have to solve an equation.